Hello everyone, and once again welcome to the Pan Future Society podcast. I am your host Sean, and today is Saturday, July 30th, 2016. One item of housekeeping to take care of. Quite a while ago, I mentioned that the comments on the website were not working because my web programming skills are not ninja level. Well, they're fixed, so now if you want to leave comments on the blog or on the podcast episode pages, you can do so. And now is the part of the show where I ramble about something off the top of my head. I have said on the show, I think a few times, maybe, and I know I've written it, maybe in the blog, that we need to be better tomorrow than we are today for the sake of civilization, for society, for our long-term survival. Now, if you were better today than you were yesterday, and if you're better tomorrow than you are today, by the time you get to the end of your life, you will be freaking awesome. So, what does it mean to be better tomorrow than you were today? It could cover a lot of ground. You could volunteer, you could donate blood, you could donate money, you could help other people somehow. You could stand up to bullies, you could stand up to bigotry and to hate. You could simply, I think, sometimes not participate. Remember, number one rule of the internet, do not read the comment section. Even though I just said, go leave me a comment, but don't read them. Just in case, we all see those stories online and we just get infuriated by reading the comment section. Just, don't feed the trolls, as they say. Another way that you can be better tomorrow is to improve yourself. And I hope that's what a show like mine can do, or if you listen to other science podcasts, you watch Khan Academy videos online. Continue your education. You should never, ever stop learning. Every day, learn something new, experience something new, and you will be a better person tomorrow for it. In fact, tonight I am going to join the Eugene Astronomical Society at a reservoir nearby for a dark sky party. So I will go get to see a great view of the night sky, which I actually haven't done in quite some time. So find your local groups like your astronomy societies and things like that and participate. Every day you learn something is another day of growth for you, and it can only make you better. All right, now on to your news of the moment. This week, a couple of items for you. The first one, follow up on my hypothesis is that the octopus will take over the world once we're gone. I saw this video online today, and I think I've seen it before. It looks familiar, but I will link it in the show notes so you can watch it. It's a short video of an octopus using two halves of a coconut as armor. The video shows it crawling across the seafloor and carrying underneath it with some of its other arms coconut shells. And it gets spooked and pulls those coconut shells around its body and kind of goes rolling off the screen on the seafloor. But I thought that was really... It's kind of funny and entertaining to watch, but also a little mind-blowing to watch this level of tool use in an animal like the octopus. So once again, octopus for successor to our planet. In the second news item this week, I wanted to talk about some of the new construction materials that are becoming common and are becoming much less expensive than they were in their experimental forms. For a number of years now, there's been a class of materials consisting of just a single layer of atoms known as two-dimensional materials. This class of materials includes graphene, made of carbon, borophene, made of boron, hexagonal boron nitride, excuse my lack of pronunciation, also known as white graphene, a material made of germanium, silicon, phosphorus, and tin is also used to make these single atom layer materials. Each of these materials has some unique properties and can afford some very interesting ways to build materials, or can build materials that have certain properties, whether it's their hardness or conduction of electricity or being impervious to water, things like that. These materials initially were discovered back in 2004. Two scientists created graphene using Scotch tape. And they were not actually attempting to make graphene, they were running some other experiment. But they used the Scotch tape to peel single layers off of some graphite. Initially, graphene cost more than gold, but improved production techniques have brought the price down enormously. The hexagonal boron nitride is also commercially available now. Graphene is now so inexpensive that it is incorporated into some water filters, which could make desalination and wastewater treatment more affordable. So all of these materials, their costs will continue to fall so that they can be used more and more widely in manufacturing processes. And these graphenes can also be added to road paving mixtures and concrete. Apparently this can also, in addition to making the concrete stronger, maybe lighter, it also can clean the air. Graphene absorbs carbon monoxide and nitrogen oxides from the atmosphere. So keep this in the back of your head. 2D materials, graphenes, and these kinds of materials look to be kind of on the verge of making a big impact on manufacturing. And that is your news of the week. All right, in the main segment this week, following up last week's conversation about space colonies, we are going to get into the idea of generation ships this week. So, what is a generation ship? Just as it sounds, it would be a spaceship on which many generations of people would live and die. They would be born, grow up, work, have families, and pass away. Depending on how far the journey was meant to be, hundreds or thousands of generations could pass before arriving at the destination. For example, the New Horizons space probe, which recently examined Pluto, is traveling nearly 37,000 miles an hour now. At that speed, it would still take 78,000 years to reach Alpha Centauri, the nearest star to our own. Space is big. If you're going, taking your time getting where you're going solves the need for some sort of warp drive or wormhole breakthrough technology. The nice thing about having no atmosphere in space, despite the fact that space otherwise wants to kill you, is that without atmosphere, the aerodynamics of your ship don't matter at all. A Borg cube is just fine a design and is an efficient use of space. So, any of the previously mentioned colony ideas from the last episode could easily become ships. Just slap some form of propulsion on your O'Neill cylinder or your hollowed out asteroid, and away you go. Under a constant acceleration of 1g, that is the gravitation that the Earth exerts on you right now, you could simulate gravity as depicted in the short-lived sci-fi channel show Ascension. Akin to flying a high-rise building, the acceleration would give the impression of gravity, and if I understand even slightly all the math I read online, you could potentially reach a significant fraction of the speed of light under this 1g acceleration in about a year. However, in any method of propulsion that reaches great speeds, you'll need to slow down. A ship such as this would have to flip around and use its thrust to slow down about halfway through its journey, which would still provide the simulated gravity. However, conventional rockets such as we have today will be wildly impractical. You would need to carry more fuel than would be possible without some sort of Trek-like antimatter fuel source. If other ship designs were used, such as the O'Neill cylinder, gravity comes from the spin of the ship itself, and the thrust could be much more gradual. A solar sail would be gradual, but not practical for any great distance from the sun. I also think that once you cross the heliopause, even if the sun could still offer a push, other interstellar particles would probably push in other directions. But here are several other possibilities for thrust, yet all with fairly daunting timescales. You could use an ion drive. Ion drive technology was used, one of the first missions to use it was the Deep Space One mission to Comet Borrelly that took place in 1998. It used a xenon-powered drive. An ion drive basically just spits a very thin stream of particles out of its thruster. This is very fuel efficient, but the acceleration is fairly slow. For example, the Deep Space One would take 81,000 years to travel between Earth and Proxima Centauri. That is the nearest star to our own. It is 4.24 light years away. 81,000 years encompasses approximately 2,700 human generations. It would be very slow, and you would have to be very certain your generation ship technology was really good. Just to clear up any confusion, I've mentioned Proxima Centauri in this example, and I mentioned Alpha Centauri earlier. Alpha Centauri is the closest star that is visible by the naked eye. You cannot see Proxima Centauri, which is a red dwarf, with the naked eye. Alpha Centauri is about 4.37 light years, Proxima 4.24 light years, and they may be gravitationally bound to each other. They are in the same area of the sky, the same system, I guess you could say. So I will try not to screw up which one is which when I'm using these examples, but all of these following ones use the Proxima Centauri as it is actually the closest to our own solar system. Moving on to the gravity assist method of traveling. This is often used by space probes that NASA launches, Voyager 1, Mariner 10, the previously mentioned New Horizons probe. The Helios 2 mission launched in 1976 to study the interplanetary space between here and the Sun, has the record for the highest speed achieved with a gravity assist. It was launched, and as it approached the Sun, it reached a speed of 150,000 miles an hour. It then again slowed down a little bit as it circled around the sun and got to wherever it was going. However, in these examples given, Voyager 1 traveling at its current speed of 60,000 kilometers per hour. That's 76,000 years and 2,500 generations to get to Proxima Centauri. The Helios 2 speed, if you could maintain that speed exiting the solar system, would still take 19,000 years. That is 600 generations. Quite a bit shorter than the previous examples, but that is still a very, very long time. Think about where human civilization was 20,000 years ago. Basically nowhere. So that is quite a bit of long-term thinking to stick with that. The electromagnetic drive is a proposed drive from 2001 using a radio frequency resonant cavity thruster. This device is experimental, and some of the recent experiments have yielded positive results, so it does appear that this could actually work. But even if it does, we are still looking at 13,000 years to reach Proxima Centauri. The next option for propulsion in space, nuclear. That's a scary word for a lot of people, but it really could be the future of a lot of energy creation. So there's two types of nuclear engines that have been proposed. One is the nuclear thermal propulsion rocket, using uranium or deuterium to heat liquid hydrogen inside a reactor, turning it into an ionized hydrogen gas, which is channeled through a rocket nozzle. The other nuclear engine design is a nuclear electric propulsion rocket, which involves the same reactor technology, but it converts heat and energy into electrical energy, which would then power an electrical engine. In both cases, the rocket would be either fission or fusion method to generate propulsion rather than chemical propellants. This has been on the drawing board with NASA for quite some time, mostly because you don't have to carry a ton of fuel with you as you do with liquid rockets or even gas propulsion of some kind. None of these types of engines have ever flown, but in some of the proposed designs, it could be possible to accelerate to a fraction of the speed of light with one of these, much quicker than anything like an ion engine would do. And it could potentially shrink that trip down to 1,000 years to Proxima Centauri. Now, that is still a very long time. So, the generation ship technology, no matter how fast we can possibly go short of some sort of wild sci-fi warp drive, the ship has to be well designed. Even the technology of it aside, there are a lot of other issues that would have to be dealt with, such as biological diversity. Some estimates put the minimum population of a ship like this at 160 people, or even with very controlled management and social engineering, down to 80 people. This would allow a 200-year journey with not too much loss of genetic diversity. Well, 200 years is still short of our 1,000-year minimum, so multiply that by 5, so, we're approaching 1,000 people at a minimum. So you're talking about a fairly large ship, something that is shielded from cosmic rays, something that has enough ways to produce food and recycle water. That is quite a large technological challenge. An anthropologist named Cameron Smith reviewed existing literature in 2013, and created a new computer model which estimated the population to need to be in the tens of thousands. This number much larger than previous ones because he was taking into account a potential large accident or disease that could severely reduce the population on board. Other problems are social in nature. People's need to have self-worth and feel like their lives are worth something. Dealing with the notion that if you're at the beginning or in the middle of this trip, you're just there to hold a place for someone else. You're going to be born and die on the ship without ever actually getting to see where you're going. So how do you deal with that social pressure, with the stresses? A larger population could help with that, just a larger variety of interaction. A much larger ship could help with that, something, on the scale of the Babylon 5 station, or something like, the original O'Neill cylinder, which was meant to be 20 miles long. In the Babylon 5 show, there are 250,000 humans and aliens on the ship. So I would think you could manage the social side of it pretty well if you had a very large population. There would likely be pockets of unrest and trouble, but you've got enough people to even that out and at least keep things interesting so people don't just lose their minds from boredom. That could be a serious problem. One interesting, I've kind of skipped over the technological side, assuming that we figured out how to build an O'Neill cylinder properly. An interesting technological problem is called the weight calculation. At the rate technology tends to improve, for example, if we sent a generation ship to a star system 20 light years away and it's supposed to reach its destination in 200 years, a better ship may be developed just 50 years from now, and therefore the second ship could get there before the first because it can travel that much faster, or it'll get there shortly after and be kind of a surprise. This is the situation that occurs in Arthur C. Clarke's The Songs of Distant Earth. People who've settled on a planet meet another ship traveling through their star system to pick up some supplies much sooner than they expect, because shortly after the first ship left, a new technology was developed to travel much, much faster. So, do we send a ship out as soon as we can, or do we try to develop a technology such as, do we send a ship with ion engines knowing it will be going very slow when maybe not too far down the road we'll have that nuclear propulsion that will go much faster? In the argument for preserving humanity and just getting us out there to the stars, I think it would be necessary to go as soon as possible. It's another safeguard against losing the only spaceship we have right now, which is Earth, to some sort of disaster. So whether it's a space colony or a ship that is actually traveling out of the solar system, I think going sooner rather than later, if at all possible, would be the way to go. Well, that is your show for the week. Thank you once again so much for joining me here on the Pan Future Society podcast. Come find us online, panfuture.org, and hey, now you can leave comments on the blog and the podcast pages, woohoo. Or you can email me, sean@panfuture.org, or you can find us on Facebook and Twitter. And next week, we are going to continue with the deep space ideas with some speculation about what we might do with genetic manipulation and the recently developed gene editing technology known as CRISPR. So join us again next week for more near and far future talk, and I will talk to you again in the future.